talking about analytical geometry. So let's first start by talking about some of the important things which you are supposed to know. One, I want to talk about the gradient. The gradient is also known as the slope, or simply change in y over change in x. So it doesn't have to be x and y. Any dependent variable divided by the change in any dependent variable divided by the change in any independent variable is a slope or a gradient. So now let's see. How do we find the slope of a line? Suppose we're given the graph, a line y equal to mx plus c. The slope is the number which you see in front of x, the coefficient of x. This is known as the slope. And to find the slope, you must use the formula change in y over the change in x, where the change symbolizes the difference or the subtraction. This means that it's a difference between any two y values on the line divided by their corresponding x values, which is x2 minus x1. So let's have an example. Suppose I'm given the points 0 and 0, which is at the origin. Let this be point A. And I'm given point B. Let this be 3 and 6. Now they say to find the slope of this line. The first thing is to identify your points. Let this be the first x coordinate, and this one is the second x coordinate. This is the y coordinate which corresponds with the first x coordinate and the second y coordinate. Now how can you find MAB, or simply the slope of AB? Well, this will be change in y over the change in x, which also reduces to y2 minus y1 divided by x2 minus xy. So what is y2? y2 is 6 and y1 is 0. x2 is 3 and x1 is 0. Now we're left with 6 over 3, which is equal to 2. This means that the slope between point A and B, if this is point A over here, point B is over there, these 2 points are joined by a straight line, and the slope of this line is 2. This is equal to m. So the slope is a straight line between 2 points. That is the change in y over change in x. So now this is how we can find the gradient of a slope, okay, of a line. Let's talk about collinear points. What do we mean when we talk about collinear? Well, it still takes us back to the idea of gradient. You must first understand what a gradient does before you understand collinear points. Let's say I'm given point A and B. If I join this by a line, any point which lies on this line has got the gradient of the slope of AB. So because in the previous lesson, let's use the same example, we had 0 and 0, and here we had 3 and 6. It's just 3 and 6, and the slope of this line was equal to 2. Because the line is straight, it doesn't change. It doesn't curve to the right, to the left, go up or down. No, it's an oblique. It increases diagonal. Any point which lies on this will have a slope of 2. So if we were to add another point, let's say point C, which also has the coordinates x1 and x2 and y1, the slope between point B and C will still be 2. Why? Because it lies on a line that has got a slope of 2. The slope of this line is 2. The gradient, it doesn't change. Okay, so when we say points are collinear, we mean that they lie on the same straight line. Okay, so collinear points, they lie on same line. they lie on the same line, and this line must be straight, of course. Okay, so let's say I'm given a line over here. Okay, pardon it, assume it's straight. So this line, point A, which has got the point XA and YA, and let's say somewhere there we have point B, which has got coordinates XB and YB, and let's say here we are given point C with coordinates XC and YC. Now, the slope of a line is constant throughout because the line is straight. Now, if I take the slope between point A and B, MAB, let's say I get B as a constant, or let me just use C since it's a constant which we are used to using. It's equal to a constant. Now, what will be the slope of BC? The slope of BC will also be the constant C. Why? Because it lies on the same straight line as AB. You see, point A, B, and C lie on the same line. So the gradient of any 2 points that lie on the same straight line is equal. So if I find the slope of AB to be 3, the slope of BC must also be 3. And the slope of AC must also be 3 because these 2 points lie on the same line. Even if I take some imaginary coordinate which might be here, and let's call this D, and another coordinate here which is F, M of DF will still be equal to C. Why? Because it lies on the same straight line. So in short, this is how we can evaluate collinear points. These are points that lie on the same straight line. So if we wanna prove that they lie between the same straight line, just prove that the coordinates, the slope between the two coordinates that lie on the same line anywhere on this line is constant. Thank you for watching.